Good morning, ladies and gentlemen. So you're going to be watching this video on the answers to Density Worksheet 1. Before we go through each problem here, we have a summary of the answers. We also have a summary of the things you need to be doing for each question. Let me start with the summary of things you need to be doing for each question. You need to be writing down the givens. That is either doing it old school, saying mass equals and then writing that down, or density equals, or volume equals, or it means writing on the question. This is M, this is D, this is V. You need to write down the equation you're going to use. Are you using density equals mass divided by volume? Are you are you using mass equals density times volume? Are you using volume equals mass divided by density? Write down the equation that you need to use to solve your problem. If you have to calculate the volume, go through that process. Is it a rectangular prism, length times width times height? Is it a cylinder, pi r squared h? Is it volume by displacement, like the water went up and you have to subtract the two numbers first? Plug the numbers in, solve, and then worry about significant figures and never forget, provide units. So let's pause the video for a second and you guys go through and check to see if you got the exact same answers as I have right here. Exact same 11 answers as I have right here. Go ahead and pause the video. I'm going to assume you just checked all the answers and now you're ready to go through the answers. Here we go. So let's go to questions 1 and 2. What amazing handwriting. Notice that I'm identifying this is the mass, this is the volume, looking for the density. I then wrote down the equation and I plugged in the numbers and then I solved. That's what you're doing. Number 1 is about as simple as it gets. Mass over volume, solve. The answer, it has 3 significant figures because you're limited by the 3 sig figs and 6.34 milliliters. Also, notice that the units are grams over milliliters and they don't simplify, so they're both in the answer as grams slash milliliters, grams over milliliters. In number 2, we have a cylinder, so we have to solve for the volume. So I have the mass here divided by the volume. And this is the volume of a cylinder equation, pi r squared h. So I said pi r divided by, diameter divided by 2 is r squared, and then the height. So when you do this, plug it in your calculator carefully. The most common error occurs right here. See how I put these parentheses in red? Put them in red because that's the thing kids mess up on. You want the mass divided by everything that represents the volume. So mass divided by parentheses, the volume equation, close the parentheses, and then you can solve. Just be careful with your order of operations when you do that. If you plug it all in a decent calculator, as I've represented here, it will do the math for you. But you have to be careful and control where you put things in. You're in charge of the calculator. My first time I rounded wrong. I had 0.911, should be 0.910, and the units are grams per cubic centimeter. Number 3, an object's volume is used measuring water displacement. Water displacement, that means that you had some water in a graduated cylinder, 70.1 milliliters. You put an object in, and it rose up to 72.9 milliliters. That means the volume of the water went up by 2.8 milliliters. And that 2.8 milliliters is the volume of the object. So we take the mass of the object divided by the volume of the object, and we have the density of the object. Number 4, we have the density, and we have the length, width, and height. Length, width, and height, man, that's how you give volume. And the equation for mass is density times volume. So I said density times length times width times height. And plugged it into my calculator, and I got this answer. Some of you love scientific notation, which is great, so you get this answer. Right? It doesn't matter which one you put down, as long as you put one of them down. There's even that one kid in the back of the room, and that kid did 12.5 kilograms. Also, a perfectly fine answer, just converted grams to kilograms. This says what is its mass, and the mass could be in grams or kilograms. And this would be a good time to switch to kilograms if you wanted to. Number 5. A sample of gold has a density of 19.32. That's very dense. A mass of gold is 56 grams. What is its volume? So a lot of kids mess this up. When you're solving for volume, it's mass over density. Down here, I've got this adorable, density triangle thing going on. And the way these things work is you cover up whatever you're trying to solve for. What are we trying to solve for in this question? What is the volume? So you cover up volume, and the equation is mass over density. So volume equals mass over density. Plug in the mass, plug in the density, and solve. First time I solved it, I somehow typed things wrong in my calculator. It happens to all of us, especially me. And I wrote 2,949. And I should have known it can't be 2,000. That's a huge volume for this tiny mass. So my students caught me, which is good. And the actual volume is 2.949. 2.949. All right, I don't have much worked out here for number 6. Let's see. We have a density. Density equals 13.6 grams per milliliter. And we have a volume of 6.78 milliliters, not megaliters, milliliters. And we're looking for the mass. Well, okay, so let's try this same idea. Gonna move this red box here. Looking for mass. Ah, it's density beside volume, so that's multiplication. So mass equals density times volume. Great. So now we're going to plug in the numbers. 13.6 times 6.78. And that is how I got the answer over there of 92.2. You know what? Let's take 2 seconds and remind everyone sig figs, right? Don't forget you need to be doing sig figs with every math problem for the rest of the year. And both of these numbers have 3 significant figures. So I only wrote down the first 3 significant figures and then rounded everything else away. Awesome sauce. I just recorded me saying awesome sauce. Yeah. Number 7. Yeah, let's pretend that didn't happen. Number 7. Sample of metal has a mass of, and has a volume of. What is the density? Okay. These are perfectly good units, even if they're weird. We're not used to kilograms per cubic meter, but that's a thing. So 12.8 kilograms per cubic meter, totally fine. It doesn't ask for the density in any specific units, so we're doing it mass per volume. Number 8. So number 8, this one's a little weird. They masked a graduated cylinder, then they put water in it, and then they masked both objects. So that's the mass of both, right? So how do we find the mass of just the water? Well, it's the mass of both minus the mass of the cylinder would give us the mass of the water. Right? The mass of both minus the cylinder would give us the mass of the water. And then I take the mass of the water divided by the volume of the water, and I've got the density of water, which is pretty much everyone should know. The density of water is 1. It's a pretty easy number to remember. Water is 1. Big yawn. Sorry about that. An object weighs 56 grams. Its density is when measured, its height is this. It's how long is it? So this is like the aluminum foil thing we did in class. Um, I have solved it all in one step here. You don't have to solve it all in one step. That's just the way I did it. So volume equals mass over density. Get the volume. And then you could say, well, volume, so the volume equals length, width, height. Ergo, you could say volume equals, what are we looking for? The length divided by the width and the height. Yeah, you could rearrange it, and that would be fine. You could do it in two steps like that. You could do volume equals mass over density and get the volume, and then plug that volume into here and divide it by the width and the height to get the length. That would work also. Either way is fine, whether you plug it in and rearrange all the variables, or if you do it in two steps. But with the significant figures, you don't want to stop until you get to the end. Compared to number 9, 10 is easy. We have a density, we have a volume, find the mass. So plug in what you know and solve. Ooh, so this one's interesting. The following graph plots the mass of volume. What is the density of gasoline? So you could pick a couple different spots. Um, a lot of people like to pick, this one here says 155 and 200. So you could do the mass of 155 over 200, because that would be the mass over the volume. That would work. I like this spot up here also because the dot hits an intersection. So you could say 600 for the mass over 800 for the volume. Either one of those answers is really similar. They're not perfectly the same. This one up here, I can do this in my head, is 0.75 grams per milliliter. And this one is just barely bigger than that. I can't do that one in my head though. Oh, but I have a calculator. Ah, that's convenient. So it's 0.775 grams per milliliter. So it's almost the same. And you can tell this dot is not quite on the line, where that appears to be perfectly on the line. There's some variation as you go up here. It's not too surprising to have some slight variation over a whole sample of data. But that, man, if you look at the slope of that line, that's a pretty straight line. And the slope in this case does represent the density. So we could have pulled a bunch of those dots, we'd have just about a 3 to 4 ratio. And then number 11 is just a bunch of densities. Alrighty, folks. Those were the answers to worksheet 1. Fantastic, and have a good day.